matrices. Learning outcomes. Find the minors and cofactors of a matrix up to 3x3 matrices. Find the determinant of a matrix. Use basic properties of determinant. Okay, so these are the basic properties of determinant. Determinant of matrices. The determinant is a useful value that can be computed from the elements of a square matrix. The determinant of a matrix A is denoted by or, okay, modulus A. Only square matrices possess determinant. For 1x1 order matrix, the determinant is equal to the element itself. For example, if A is equal to -3, then the determinant of A is -3. For 2x2 order matrix, the determinant of A, B, C, D, defined by AD minus BC. For example, if A is equal to 7, 5, -1 and 9, then the determinant of A is just 7 times 9 minus -1 times 5. And that is equal to 68. For 3x3 determinants, we will discuss later. Given that A equal to 2538 and B 3252, find determinant of A and determinant of B. So we have 2 times 8 minus 3 times 5. That gives you 1. So for determinant B, so we have 3 times 2 minus 5 times 2. That gives you -4. Minor, cofactor and determinant of 3x3 matrices. So minor is the determinant of the submatrix formed by deleting the ith row and jth column. Cofactor is obtained by multiplying the minor by -1 to the power of I plus j. That is, okay, sign of cofactors, plus minus minus and then plus minus plus minus plus. Okay, let A be a 3x3 matrix. The determinant of matrix A is the summation of the product of Aij and Cij of a row or column of A. The determinant of matrix A based on ith row is given by, okay, determinant of A is equal to AI1 Ci1 plus AI2 times Ci2 plus AI3 times Ci3, while the determinant of a matrix based on jth column of the matrix is given by determinant A equal to A1j times C1j plus A2j times C2j plus A3j times C3j. Okay, given matrix A, find minor M11. So the entry A11 is here. Okay, you have to close these. Okay, so you get 0, 2, 1, 1. So the determinant of the submatrix is 0 times 1 minus 1 times 2. You get -2. So for M23, so second row, third column, okay, second row, third column, you have 2, 3, 2, 1. Okay, and the determinant of the sub matrix will be 2 times 1 minus 2 times 3. You get negative 4. We're going to find the cofactor. Let's go through the notes again. Okay, so the formula to find cofactor is negative 1 to the power of I plus j times with minor m. Okay, so to make things easier for you, you can just refer to the sign of cofactors. Okay, so I've copied that here, the sign of cofactors. Okay, so for C11, I refer to the one I've highlighted in green. So C11, the sign is plus, and then the minor for 11 is negative 2. Right here. So just copy it here. And then you just need to simplify. You get negative 2. Okay, and then the one in yellow for C23. Okay, second row, third column. So the sign is negative, and then the minor for 23 is negative 4. So just put that here, and then simplify, you get positive 4. And lastly, you have C31. The sign is positive, and then the minor is 6. So get positive 6. Moving on, example 8. So given A, find the cofactor of matrix A. Okay, so you just need to find all the cofactors one by one for each entries. For each entry. Okay, so let's focus on the minor. Okay, so this one, that would be 2, 2, negative 1, 0. And then the submatrix for 1, 2 is 0, 2, negative 2, 0. And then submatrix 1, 3 is 0, 2, negative 2, negative 1. Then for the second row, first column, get 3, 2, negative 1, 0. Second row, second column, 1, 2, negative 2, 0. And then 1, 3, negative 2, negative 1. And then 3, 2, 2, 2. 1, 2, 0, 2. Lastly, we have 1, 3, 0, 2. And as you can see, I've written all the signs for the cofactor. Now we just need to find the determinant of the submatrices and times with the sign. So you have 2, negative 4, 4, negative 2, 4, negative 5, 2, negative 2, 2. So this is the cofactor of matrix A. Okay, next. Using the expansion of the first row, find the determinant of matrix A. So let's refer to the first row. Okay, this is the first row of A. You have 1, 3 and 2. Okay, I've written down the entries 1, 3 and 2 and the sign for covectors. Okay, positive, negative, positive for the first row. Like this. Sorry. This one right here. And for the submatrix 2, 2, negative 1, 0. And then 0, 2, negative 2, 0. Lastly 0, 2, negative 2, negative 1. Okay. So now we just need to find the determinant of the submatrices and times it with the entry and the sign, covector sign. Okay, so 1 times 0 minus negative 2, and then minus 3 times 0 minus negative 4, and this one is plus 2 times 0 minus negative 4. So you can simplify that and get negative 2. Question C. Using the expansion of the second column, find the determinant of matrix A. So the entries on the second column is 3, 2, negative 1 and the sign is negative plus negative. Okay, so you have negative 3 plus 2 and then minus negative 1. And for the submatrices, start from here. We have 0, 2, negative 2, 0. Okay. And then 1, 2, negative 2, 0. Then lastly, 1, 2, 0, 2. Okay. So let's find the determinant of the submatrices. So 0 minus negative 4 plus 2 times 0 minus negative 4 plus 1 times 2 minus 0. So simplify it and you get negative 2. As you can see, the answer is just the same as question B. Okay, so if you calculate determinant of A using any column or any row, you'll just get the same answer. It doesn't matter any rows or columns you use. This of determinants, if any row or column of a matrix A is 0, then the determinant of A is equal to 0. If any row or column of a matrix A is multiplied by non-zero constant K to produce a matrix B, then the determinant of B is equal to K times the determinant of A. As you can see here, the last row is multiplied by 2, so the determinant of B will be 2 times the determinant of A. Then you get negative 4. If all the rows or columns of a matrix A are multiplied by non-zero constant K to produce a matrix B, then the determinant of matrix B is equal to the determinant of K times A, which is equal to K to the power of N times the determinant of matrix A, where N is the number of row or column. So as you can see here, times everything by 2, okay, times each entry by 2. So all the rows times by 2. So the determinant will be 2 to the power of 3, which is the number of rows here. 1, 2, 3, you have 3 rows. So to the power of 3 times the determinant of A. Okay, so you get negative 16. If a square matrix A has one row or column that is a scalar multiple of another row or column of A, okay, for example this one, 3, 7, 4 times 2, you get 6, 16 and 8. Then the determinant of A is equal to 0. If two rows or columns of a matrix A are interchanged to produce a matrix B, then the determinant of B is equal to negative determinant of A. Okay, interchange these two columns, you get the second matrix here. So then the determinant of the second matrix will just be negative of the first matrix. Then you get 2. Okay. Okay. The determinant of the transpose of A is just equal to the determinant of A. For square matrices A and B of equal size, the determinant of A times B is equal to the determinant of A times determinant of B. Okay. So you can see here, determinant of A is equal to 1, determinant of B is equal to negative 4, then the determinant of AB is equal to negative 4. Given the determinant of 2, 1, 4, 5, negative 1, 3, 7, 5, 6 is equal to 7, 7, evaluate the following using properties of determinants. Okay, so for question A, as you can see, 2, 5, 7, 2, negative 1, 5, 1, negative 1, 5, 4, 3, 6 is just the determinant, it's just the transpose of the given matrix above. Okay, so let's just rewrite that. 4, 5, negative 1, 3, 7, 5, 6 transpose. So, okay, and you know that from the previous page, that the properties of the determinant of matrix A and its transpose is just the same. So you have 2, 1, 4, 5, 1, 3, 7, 5, 6. Okay, so these two have the same determinant. Okay, so you know that for A, the determinant is 77. Let's see question B. 2, 1, 4, 7, 5, 6, 5, negative 1, and 3. Okay, trying to find the relation between matrix B and the given matrix above. Okay, if you see it closely, you can see that these two rows were interchanged. Okay, you swap these two rows, you get the matrix in B. Okay, so from the properties, you know that this is equal to negative determinant of 2, 1, 4, 5, negative 1, 3, 7, 5, 6. Okay, so you just need to times it by negative, so negative 77. Then lastly, question C. Okay. Oops, sorry. Okay, so you can see that if you time this by 2, this row by 2, you get 4 to 8. And then this one right here will be 10, negative 2 and 6. Then times this row by 2, you get 14, 10 and 12. Okay, so you times everything by 2. So you have 3 rows. So 2 to the power of 3. Determinant of 2, 1, 4, 5, negative 1, 3, 7, 5, 6. Okay, so you just need to times the determinant by 8. Then you get 6, 1, 6. Matrix A is as such, and the determinant of A is negative 15. By using properties, find the determinant of matrix B and C. So let's take a look at matrix B first. Okay, if you interchange the rows, okay, then the determinant of the new matrix times negative will still be the same as the determinant of matrix B. Okay, so the determinant of this matrix times negative will still be the same as the determinant of B, right? Okay, and then if you interchange the rows again, I mean this row, okay, with the next row, okay, you interchange them, you need to times by negative again, so this will be positive. Okay, then to change the rows, you get 3, negative 1, 1, negative 5, 0, 0, 4, negative 1 and 2. Okay, then you can see that this matrix is just the same as matrix A. So the determinant would just be negative 15, same as A. Okay, you interchange rows twice, so times by negative twice will just be the same thing, so negative 15. Then for matrix C, okay, you can interchange these two columns, okay, to get this to the front, negative 5 to the front. You need to times it by negative, okay, and then you just need to interchange the rows. Okay. Then again, by interchanging the rows, you need to times the determinant by negative again. So negative times negative, okay, you get positive. Then you can see that this matrix is just the same as matrix A. So the determinant of C is just negative.